All right, welcome to today's YouTube video. And on this video, we're going to be looking at linear approximation, quadratic approximation, and cubic approximation. Now, um, our first question here, we have find the linearization of g of x equal to log of x squared about x is equal to 1. So we have g of x is equal to log of x squared, and we have about x is equal to 1. Now, one thing I want you to understand is that whenever you're giving linearization question, this particular one is linearization. It could also be called linear approximation. So whenever you see find the linearization or find the linear approximation of such a function, then you are dealing with a Taylor expansion, right? So now, but when you see linearization or linear approximation, it means that you are stopping at the second term of the Taylor expansion, right? Now, just to refresh our memories on what Taylor expansion is or what Taylor series basically is. For Taylor series, when you have a function f of x, it is the expansion is going to be of um, f of a plus f prime of a multiplied by x minus a all over 1 factorial plus f prime prime of a multiplied by x minus a squared over 2 factorial plus f prime 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 of a multiplied by x minus a cube over 3 factorial, and we keep on going like that, like that, like that. We keep on going. So this is basically what we mean by Taylor expansion, right? This particular formula, and this is what we're going to use for linearization, linear approximation, quadratic approximation, and even cubic approximation. Now, how does this work? Whenever they give you a question on linear approximation, you take just this first term and this second term, right? But now, if it comes to quadratic approximation, you are going to stop here. And then if it comes to cubic approximation, you're going to stop at this third term, right? So you stop at the fourth term for cubic approximation, right? Let me just see if I can write that somewhere. For linear, quadratic, and cubic, for linear approximation, you stop at the second term of the Taylor series expansion. For quadratic, you stop at the third term, and then for cubic you stop at the fourth term of the Taylor series expansion. Now, having this at the back of our mind, we can easily solve any question under linear approximation, linearization, quadratic approximation, and even cubic approximation. Let me go ahead, let me just rub this off so that we can solve this question before us. Right. So now this question that we have here, g of x is equal to log of x squared about x equal to 1. So first thing we're going to do is we're going to find g prime of x, which is basically we're saying we're finding the derivative of g of x. Since we're doing linearization, this is the only term that we need to actually find because we already have this, so we just need to find this. Do you understand? Now, we're going to be doing differentiation a lot when it comes to linear approximation, quadratic approximation, and even cubic approximation. So your knowledge on differentiation has to be very, very good. You can go and check the videos on differentiation of log functions, the differentiation of exponential function and trig functions, because you will see questions that have to do with logarithm or exponent or trig, just like we are seeing here. Not every time you see basic questions. But here we have g of x equals to log x squared. So now, right, so now we're going to be solving this question. G of x is equal to log x squared about x is equal to 1. Now, one thing I want you to understand here is that the alphabets here are not really that important. What they just mean is they mean you're talking about the function, right? So g of x is still the same thing as f of x. Just to prevent ambiguity, we're going to write our g of x as f of x, right? So that it's not confusing. So we have f of x equals to log x squared. Now, remember, this is linearization, this linear approximation. I remember I said that for linear approximation, you use the first two terms. So we're using this term, and then we are using this term, right? For this term now, we have f prime of a. So that means for here, we already have f of a. Now, what we're going to do very quickly now is that we're going to first find f prime of x. because we need it. This is going to be our second term, right? And then we're going to differentiate this, which is going to give us 2x over x squared, which is going to be 2 over x. If you do not understand how I do this, please go and check the video on differentiation of log function in the channel. Check, also go through the one for exponential function, refresh your memory on even on the one on trig function, because you're going, when you are dealing with linear approximation, quadratic approximation, and cubic approximation, you'll be seeing functions that have to do with trigonometry, exponents, and logarithm, right? And you need differentiation. So it'll be nice to refresh your memory about the differentiation of these different functions. So we have this basically. So now the next thing we're going to do now is find f of a, right? What this basically means is that wherever we see x, we're going to represent it with the value of a. Now, what is a? X is equal to a. So that means a in this question is equal to 1. So a is equal to 1. So wherever we see x, we're going to replace it with the value a. So f of a is going to be equal to log of 1 squared, right? So this was to be like this. Yes, log of 1 squared, which is going to be log 1, which is going to be 0. Log of 1 is 0. Then we have f prime of a. So f prime of a is going to give us 2 over 1, right? Because this is f prime, right? F prime of x. So now since we're representing it with a, and a is 1, so we have 2 over 1, which is going to give us 2. So we have this. So now that we have these two functions, we can just plug it into our formula and then we solve, right? So we're going to say f of x is equal to f of a, which is what? Our f of a is 0, then plus f prime of a, which is 2, multiplied by x minus a. And what is our a? Our a is 1. Remember, this is linear approximation, so we're stopping at the first term and the second term. Once we get to the second term, we stop, right? So we have f of x equal to 0 plus 2 x minus 2. So this is going to be our final answer. Or your final answer could also be 2 into bracket of x minus 1, depending on the options that you see. Whichever one is the answer. So this is the linear approximation of g of x is equal to log x squared. Now, if they ask you to do quadratic approximation, then you know you are stopping at the third term. You're not going to stop at this second term. So on let's take a question on quadratic approximation, and then we take one on cubic approximation, and then I have a bonus question at the end, a question that has to do with a bivariate variable, right? So we see how we take linear approximations of bivariate variables and then we solve them. All right, so now the second question says if f of x is equal to e to the power of minus 2x. So now you can see this is an exponential function. So if you do not know how to differentiate exponential functions, it might give you problem solving. So this question is asking us to find the quadratic approximation of f of x about the origin, right? So it's asking us for quadratic approximation about the origin, right? Now, unlike the first question that we did on linear approximation, for that question now we saw that it said about x is equal to 1. This question now is telling us about the origin. Whenever they give you a question that says about the origin, it automatically means that your x is equal to 0. Whenever you see that statement about the origin, it means that your x is equal to 0. So now that we have that out of the way, we are looking for quadratic approximation, which means we are going for the third term. We are stopping at the third term. So now we're going to first find f prime of x, which is going to be equal to minus 2 e to the power of minus 2x. Please, if you do not understand how I differentiated this, please go and watch the video on exponential differentiation of exponential functions. Then we're going to go for the third term, which is f prime prime of x, which is going to be equal to 4e to the power of minus 2x. So now that we have gotten the three terms, we're going to find the fa. Fa is going to be e to the power of minus 2. And now remember, anywhere we see x, we're going to be putting the value of e, which is 0, right? So this is going to be e to the power of 0, which is 1. Then we have f prime of a, which is going to be minus 2 e to the power of minus 2. Anywhere we see x, we put 0. So we have minus 2 e to the power of 0, which is going to be equal to minus 2 times 1, which is minus 2. Then the last one, f prime prime of a, which is going to be 4 e to the power of minus 2, 0. That's going to be 4 times 1, which is equal to 4. So now we've gotten our three terms. Now let's solve. So we have f of x to be equal to, don't forget our formula is f of a plus f prime of a multiplied by x minus a over 1 factorial plus f prime prime of a x minus a squared over 2 factorial. This is our first term, this is our second term, and this is our third term. So let me increase the thickness of the pen. All right, so we have this. So we have this is our formula, right? Since it's quadratic approximation, we're stopping at the third term. We're stopping at the third term, right? So now let's solve, let's combine. So we have f of x to be equal to f of a, which is 1, right? 1 plus f prime of a, which is minus 2. So put that in bracket, minus 2. Then we have multiplied by x minus a, which is 0. So that's basically just x. Then we have plus the last term, which is 4. Then we have x minus a squared, which is x minus 0, which is x squared. Then we have over 2 here. So we have f of x to be equal to 1 minus 2x plus 2x squared. So this is our quadratic approximation. Now, if you look at this quadratic approximation, you can see that it has x squared. And don't forget, the general form of a quadratic equation is ax squared plus bx, right, plus c equals to 0, right? So when you get something like this, you know that yes, you are on the right track and what you did is correct. Now we're going to be taking one example on cubic approximation. One example of cubic approximation. So just like your linear approximation and quadratic approximation, you are still going to be using Taylor expansion. And but for cubic approximation now, you are stopping at the fourth term, unlike the quadratic approximation where you stopped at the third term and the linear approximation where you stopped at the second term. Now the question goes, find the cubic approximation of g of x, right? G of x equal to sine x about x is equal to 0. We're doing cubic, so we're going for the fourth step. So we're going to go g prime of x. This is the derivative of sine x. This is the differentiation of trig functions. There's also a video on that. So this is cos x. We have g prime prime of x, and this gives us minus sine x. Then we have g prime 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 of x, which is going to give us minus cos x. So we have 1, 2, 3, 4, 4 four values, and then we stop here, right? We stop at the four terms, so we stop here and then we just apply our formula. So we're going to go for g prime of a, which is going to be cos of 0, because a is what? A is 0 and cos of 0 is 1. Then we'll go for g prime prime of a, which is going to be minus sine 0, which is 0. Then we have g prime 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 of a, which is minus cos 0, which is equal to minus 1. Then don't forget we have g of a, which is equal to sine of 0, which is equal to 0. So we have this. These are our values. So we're going to just write our formula. So we have g of x is equal to g of a plus g prime of a in bracket x minus a over 1 factorial plus g prime prime of a x minus a squared over 2 factorial plus g prime 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 of a x minus a cube over 3 factorial. And now we can stop because we have gotten our first term, second term, our third term, and then our fourth term. So all the terms are complete. So g of a is 0, then plus g prime of a, which is 1, multiplied by x minus a, which is 0. So this is just x. Then we have plus g prime prime of a, which is 0, multiplied by everything will just give us 0. Then we have the last one, which is going to be plus then g prime 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 of a, which is minus 1, multiplied by x minus a, which is x minus 0, which is x cube, then everything over 3 squared. So here we're going to be having 0 plus x plus 0. Then here we are going to have minus x cube over 3 factorial, which is 6. So that means our final answer is going to be x minus x cube over 6. Very, very simple stuff. You do this and then you get your full marks. So this is for cubic approximation. So we have touched every single one of them: linear approximation, quadratic approximation, and cubic approximation. So now I'm going to solve a bonus question that has to do with a bivariate variable. Let's see how that looks like. Now, bivariate variables are variables that have like two different functions, right? They have x and y together, right? Unlike the ones that we have been doing since we had just x, right? G of x. Now, what will happen if we have g of x of y, right? They are going to solve it in a slightly different way, but still the same process, right? So now the question goes: find the linearization of f of x of y equal to e to the power of x cos y at the origin. At the origin. Remember, I already said that whenever we have a question and the question says at the origin, then it means that we are going to be taking our a to be 0. Right? So we have cos y, then we have x equal to 0. We have our x to be equal to 0. So this is the function. Now you have a bivariate, we have x and you have y. So how do we do this? Remember, this is for linear approximation, right? So now because we have this, that means we're looking for just the first term, but it is a bivariate variable, right? So that means we're going to take the first derivative of the function with respect to x and the first derivative of the function with respect to y. If we are going to be doing for quadratic approximation, then you know we're still going to take the second derivative with respect to x and the second derivative with respect to y. So we're going to be having those values, right? One for x and one for y because it's a bivariate variable. So now this one, when you differentiate with respect to x, we're still going to have e to the power of x cos y. Then when you differentiate with the power with respect to y, you're going to be having minus e to the power of x sine y. If you do not understand how this magic was performed, please go and watch the video, and I believe that you will be able to get it. Right now, our f, let's write our formula. So our f x of y is going to be equal to f of a comma a, right, plus f prime of x a, then we have x minus a over 1 factorial plus f prime, then the one for y, right, the one for y, x minus a over 1 factorial. So that's how you do it when you are dealing with bivariate variables, right? Because you're having two different variables, so you are going to do the one for x and then the one for y, right? So we're still having two variables, just that we're having two terms. It's just that we're now adding an extra one for the second variable. So f of a, let's do f of a comma a, which is going to be this expression here. Now a is 0, so that means we're going to put this first a here represents x and this second one represents y, right? So wherever we see x, we're going to put the value of a, which is 0, and wherever we see y, we're going to put 0. So we have e to the power of 0, then we have cos 0, right? E to the power of 0 is basically 1, because anything is about 0 is 1. Then we have times cos 0, which is 1. So that means we have 1, right? We have 1. So now we're going to do f prime x of a, which is going to be e to the power of 0 cos 0, which is also going to give us 1. Then we have f prime y a, which is going to be minus e to the power of 0 sine 0, which is going to be minus 1 times sine 0, which is 0. So this is going to give us 0. So now imputing our values, we have 1 for this, then we have plus 1, then we have x minus a, which is basically x minus 0, which is x, then we have plus this gives us 0, then we have x minus 0. So this is going to give us 1 plus x. 1 plus x is going to be our answer for this particular question, right? So the knowledge of differentiation is very important, and then the knowledge of Taylor series is also very important. So once you know the formula, you are good to go. Remember, linear approximation, you stop at the second term. For quadratic approximation, you stop at the third term, and for cubic approximation, you stop at the fourth term, and then you're good to go.